Let's take a look at a question where we're asked to build a 90% confidence interval to estimate for an unknown population proportion, and that proportion happens to be the percentage of cell phone users who develop cancer of the brain or the nervous system. So this question is asking us to estimate for an unknown population proportion, which is what we call P. So P here is unknown, and again, P represents the percentage of cell phone users who develop cancer of the brain or the nervous system. Okay, all right, so I'm going to jot down some information here that's going to help me if I'm using the formula, and also information that I'll need if I'm using the calculator function to answer this question. So 90% confidence interval means my confidence level is 0.90. And if that's 0.90, that means that my significance level, which is alpha, is going to be 1 minus 0.90 or 0.10. So if you're building a 90% confidence interval, it's going to look like this on the bell-shaped curve. So at the center here, the area in the center is going to be your confidence level of 0.90. And then alpha is going to be split equally in the left tail and the right tail. So on the left tail is going to be alpha divided by 2. So if alpha is 0.10, if we divide that by 2, that's going to give us 0.05 on the left and an area of 0.05 on the right. Okay, so why do I need to know this? Because when you're building the confidence interval and you're estimating for P, that confidence interval involves a lower confidence limit, which is your sample proportion minus your margin of error, and then the upper confidence limit is going to be your sample proportion plus your margin of error, which means we need to figure out what is the margin of error for a 90% confidence interval. Well, there's a formula for calculating that margin of error, and that formula involves a critical value that we call z sub alpha divided by 2. Once you know this critical value, you're going to take that and multiply it times the square root of your sample proportion, which is p hat, times 1 minus p hat all over n, where n is the sample size. So I need to also write down what n is. So in this particular problem, we're told that a study of 420,067 cell phone users, all right, 0.0333% of them develop cancer of the brain or nervous system. So we need to write this information down as well. I'll write it down in blue. So here what we have is, let me finish writing this. This was a critical value. Okay, so in blue, we have our sample size. N is 420,067. And then p hat in the problem is given to us as a percent. But if I'm using formulas or the calculator function, you always want to convert this percent to its equivalent decimal. So as a decimal, that's going to be 0.000333. Okay, and the other piece of information that the problem does not give us, but we can still calculate it because we know n and we know p hat, is x, where x represents the actual number of people who develop cancer of the brain or the nervous system by using cell phones. So how do we get x? To get x, you just take your p hat and you multiply it by n. How do I know that? Well, I know that because to get p hat is x divided by n. So if we just work backwards, right? If p hat is x divided by n, then working backwards to get x, we just take p hat and multiply it times n. So that gives us 0.000333 times 420,067. Okay, so moving down here, put that into your calculator. It's going to give you 139.88, but we don't want fractions of a person, so just round that up to 140 people who developed cancer of the brain or nervous system from using cell phones. Okay, we're going to need this piece of information later on if you're using the calculator function. But right now, I'm going to show you how to use the formula to get your confidence interval. Okay, so again, that formula, we know what p hat is, so we know the value of p. Oh, let me use my highlighter here. So I know that p hat is 0.000333, so I know that I can put that into the formula, but we need to calculate e so that we can use that in the formula. So how do I get e? I need that critical value, z sub alpha divided by 2. So where do we find that on the bell-shaped curve? Well, that z-score is going to be the so that critical value is going to be the z-score that separates the area on the left tail here, so that's going to be negative z sub 0.05, but there's also a corresponding positive value on the right-hand side. So this z-score that separates the right tail is positive z sub 0.05, and in the formula, we want positive z sub alpha divided by 2. So here, if you go to your calculator, you can use the function on your calculator called inverse norm. Inverse norm is going to ask you to put in the area to the left. So it doesn't matter if you calculate this critical value on the left tail or the one on the right tail. If you use the one on the left tail, inverse norm is going to give you a negative critical value, and then you know that to get the right tail, it's just the positive value. So I'm going to go ahead and show you what happens if I put in the area in the left tail here. So inverse norm is always going to ask you to put in the area to the left. So if I put in an area of 0.05 and then put in mu and sigma on the standard normal distribution, mu is always 0, sigma is always 1 on that standard normal distribution, you're going to get negative 1.64. So that means that this critical value that separates the left tail here, that's negative 1.64. So that corresponding critical value on the right tail here, that's going to be positive 1.64. And we're going to use that positive value in the formula here. So down at the bottom here, let's calculate that margin of error. That's going to be 1.64 times the square root of p hat, which is 0.000333, times 1 minus p hat, okay? And then divide that whole thing by the sample size of 420067. You put this all into your calculator. Your calculator is going to give you a margin of error, and it's going to look like this. It's going to read it as 4.617, and then you're going to see E negative 5. So if you've never seen this before, this is your calculator's way of writing a really, really small number using scientific notation. So if you recall scientific notation, it's a way of writing really large numbers or really, really small numbers using base 10. So you just have to convert this to its equivalent decimal. So this is basically 4.617, and whenever your calculator says E negative 5, that means times 10 to the negative 5th power. So that means take this decimal point and move it 5 places to the left. So if I move it 5 places to the left, it's going to give me a decimal of 0.0004617. And this value right here, my friends, is your margin of error. And that's what you're going to take to subtract from p hat to get your lower confidence limit. And then you're going to add it to p hat to get your upper confidence limit. So I'm kind of running out of space here, so I'll use red and I'll write on the top of the screen. To get this lower limit, you're going to take your p hat and you're going to subtract e. So I'm going to take 0.000333 and subtract your margin of error of 0.0004617. Again, if you're using your calculator is going to write that value as 2.89 e to the negative 4, which is 0.000289. That's your lower confidence limit. Now to get this upper confidence limit, take p hat, 0.000333, add your margin of error of 0.004617. Your calculator is going to give it to you as 3.8 times e to the negative 4, which is 0.00038. So final answer, I will write it in blue at the bottom, okay? The confidence interval, so the 90% confidence interval, is the interval from 0.000289, right, to 0.00038. So this means that we are 90% confident that the actual percentage of cell phone users who develop cancer of the brain or the nervous system is somewhere between 0.000289 and 0.00038. Okay, all right, next I'll show you how to do all of this on your calculator. So on the calculator, if we want to build a 90% confidence interval, our confidence level is going to be 0.90, so we need that piece of information. We also need to know X, which is the actual number of people who develop cancer of the brain or nervous system using cell phones, and so we calculated that earlier as 140 people. And then our sample size is 420,067. Then just off to the side here, recall that the sample proportion that we were given in the problem was 0.000333. So I'm going to just jot that down so I can check my calculator later. Okay, so if I want to build a confidence interval, then you go to your calculator and you press the stat button, and then you're going to go to your tests, and then you're going to choose one proportion Z interval. So 1 because we have one sample, right? Proportion because you're estimating for a population proportion P, right? And we always use the Z interval anytime we're dealing with a proper, or excuse me, we always use the Z or the normal distribution anytime you're dealing with a population proportion. And then the word interval means that you're trying to build a confidence interval. So now that you know which function to use on your calculator, you're going to choose that function, and it's going to ask you to type in all the relevant information that you already wrote down on your paper off to the side here, and then it's going to give you the answer. So notice that it gives you the confidence interval first, and then also gives you p hat. So again, you can check to make sure that it matches up with what was given in the problem. And again, notice your calculator gives it to you in scientific notation because these values are really, really small numbers. So here, 3.33. You know your sample proportion is a decimal. It's going to be some value between 0 and 1. So the fact that you just have the 3.33, you know you're not reading the problem correctly because the sample proportion is always a value between 0 and 1. So it can't be anything bigger than 1. So here it's telling you don't ignore the last part of the answer. So 3.33, all right, e to the negative 4 means times 10 to the negative 4, which is 0.000333. Okay, it matches up. Okay, let's talk about the final answer. So your calculator gives you the confidence intervals between 2.87 times 10 to the negative 4 up to 3.8 times 10 to the negative 4. Again, that's what the e to the negative 4 means. It means scientific notation. So now let's convert these values to a decimal. That's 0.000. So I'm going to move this decimal place 4 places to the left. So that's 287. And then the upper confidence limit, take this decimal, move it 4 places to the left. That gives me 0.00038. Notice this answer matches up with the answer that we got using the formula. So you can either write your answer using the interval notation, or you can use this notation, which is basically p hat minus e. It's less than p is less than p hat plus e. So then again, you can write your answer using either notation. And I'm okay with whichever notation you want to use. So final answer.